So this is going to be the second lecture of electric circuits, and in this lecture we are going to see that what are the different components there in a circuit which we actually need to understand. We are going to look at some single loop circuit, another type of circuit which is called Wheatstone Bridge. Then we are going to see how the combination of batteries look like.
Mm,
Lastly, we are going to talk about power, that how much power a device generally consumes and how can be calculated. Last, not the least, again, the energy losses because of the conductor. So there
mm,
is a resistance which do cause energy losses in the circuit, and not all the energy which is being given out by the battery is used by the component there in the circuit. So what is the energy loss and how can we calculate it? So these are going to be the topics we need to study today. Let's start with the question. And this question is based upon what we did yesterday only. Because whatever we did yesterday, we need to have that knowledge in today's class in order to understand each and every topic.
mhm,
So, can you try this? The question says
mhm.
that there is a 66 amperes of current which is coming towards the circuit, and there are three resistors which are connected in parallel. We have to find the current in each branch. So, like there is something I1, we can say there is something I2, and there is something I3. We can assume. So, all the three branches will have different current. So, how can we calculate that current? Any idea? So, we'll use all the methods to solve it. First, and you can say the elementary method to do such problem using Ohm's law.
Mhm.
So first we are going to solve this problem using Ohm's law, and then we'll be solving this problem with some another method. So the Ohm's law says that the potential across all the wires, or you can say the all the resistors, should be same. So we can try that potential, and that potential is nothing but I times R, where this R is R net. So how can we calculate that net resistance here in the circuit? Like by using parallel combination rule. So we know
Mhm.
that in order to calculate net resistance in parallel combination, the formula which we use is nothing but reciprocals of sum of resistors.
Mhm.
So that will give us 1 by 1 plus 1 by 2 plus 1 by 3. When we solve it, we'll have like 6 as an LCM in the denominator,
Yeah.
6 plus 3 plus 2, which is approximately 11 by 6. So the net resistance here in the circuit would be 6 by 11 ohms.
Why is it 6 by 11? Oh,
Because we
because
have
it's
to reciprocal it in order to find the value of net resistance.
okay.
Next, we can find out the potential, which is I times this. So I is something 66 and R is something which we just found. So
So
it should
6
be
times 6
66 times
and
6 by 11, which is approximately 6 times 6. So the
36.
potential would be 36 volts.
Mm.
Now, as we got the potential, we can find out the current in each branch, like how it will goes. See. So I1 is going to be V by R1, which is going to be 36 by 1,
36.
that is 36 volts,
Oh, and then
36
it's
ampere.
what I2 is V over R2, which is 36 by 2,
Yeah,
which would, yeah, 18. And then I3 is V over R3, so 36 over 3, so 12.
it's not 18, it's 30, it's something else.
No, it's 18, right? 36 by 2. No.
Not 36 by 2. 1 second, yeah, 36 by 2. 1 second, let's see. Potential is 66 volts. Yeah, it's correct. Yeah, it should be 36 by 2, that is 18, and it should be 36 by 3, that is 12 amperes. So these are the values of current in each branch. Now, is
Mm-hmm.
there any other another method to solve such problem? So the answer is yes. We can solve such problems analytically as well. So method two is simply by using common sense, as we already discussed it. Like higher the resistance, lower will be the current passing through it. Lower
Mm-hmm.
the resistance, higher current will pass through it. We can also see the same by looking at the answers which we got using Ohm's law. Net resist R1, from R1 maximum current is passing, and from R3, that is 3 ohm, minimum current, that is 12 ohm, is passing through it. So how can we find this analytically? What you can do is just find out the ratios of the resistance in this case. So it should be 1 is to 2 is to 3, right?
Mm-hmm.
So the ratios of current through each wire would be the reciprocal of each. That is 3 is to 2 is to 1. Also, one more thing, it's better that we go through analytical method. Let's drop this one. First of all, let's be generous and solve questions with the one concept. Let's follow this one. All right.
Mm-hmm.
So next, you have a same question. Now you tell me, you solve it and tell me what should be the values of current passing through each branch. Same thing I can assume that I1 current must be passing through it, I2 current must be passing through it, and I3 current must be passing through it. And this
Mm-hmm.
is nothing but 20 ohm, 20 amperes. So how can we calculate it? Again, first of all, we have to calculate net resistance, which is again in parallel combination. It should be 1 by 1 by plus 1 by 2 plus 1 by 2. So it is approximately 2 by 1. So RP is going to be 1 by 2 ohm.
Mm-hmm.
So potential is something we can say I by R, I times R. So I is 20,
So
R is
10.
1 by 2, so 10 volts. Again I1, V times V by R1. That is,
So 10 by I1 is 10 amperes, and then
what is
I2 is
I4?
I2 and I3 are both 5 amperes.
Yes. So a very general way, just make it strong. If you are able to solve question through this method, another method will you'll get that other method automatically. You won't be even
Mm-hmm.
writing to find the answers. All right. So this is something that we should keep in our mind before looking at the concepts. So the first topic here is combination of voltmeter. Like how can we use voltmeter in a circuit? Before that, we need to understand that what is voltmeter. Do you have any idea what is voltmeter?
It just measures like how many volts are.
Yeah. So it is a device which measures the potential difference across 2 points in a circuit.
Mm-hmm.
Another important thing about voltmeter is that in order to measure the voltage, it it is always connected in parallel combination. Like whenever you are connecting voltmeter, it should be connected to the
Mm-hmm.
connected with the component given in a circuit in parallel combination only.
Mm-hmm.
So voltmeter is something which is represented by this symbol. This is the symbol of voltmeter. And again, remember this thing, it is always connected in parallel.
Mm-hmm.
So you can assume if we have a circuit like this, and this is the resistance R1, this is the resistance R2, this is potential V. And the examiner says what is the potential difference across R1. So in order to find the potential difference, what we do is we just connect the voltmeter in this way, like in parallel combination. And whatever reading we get for the voltmeter, it will give us the potential across R1 resistor.
Mhm.
This is how we can use it.
Mhm.
So whenever you see that there is a circuit and the circuit shows a voltmeter connected across any element, so it possibly that the examiner will ask you to find the potential across that given component. So let us see
Mhm.
some problems and it will be easy for us to understand. So what is the reading of the ideal voltmeter? It says. So ideal voltmeter means no resistance. Like voltmeter is again a component which is used in the circuit, but sometimes it do possess some resistance.
Mhm.
So if there is a resistance, we have to consider that resistance also in order to find out the correct value of whatever we are finding. So it do possess resistance sometimes, but the ideal voltmeter has no resistance. But the ideal voltmeter has no resistance. So as the question says it is ideal, so there must be no resistance.
Mhm.
Now this is a little complex problem, and we should assume that the voltmeter is connected across this resistor. It would make it easy. So just assume that this is the circuit we have and it is connected across a 2 volts battery. Also, with the circuit, there is a voltmeter attached to this resistor like this. So the question says what is the value of potential across the given component? It is 20 ohm, it is 30 ohm, again it is 30 ohm, it is 20 ohm. The potential of the
Mhm.
battery is 2 volts. So how can we find the reading of the voltmeter? In order to find the reading of the voltmeter, first of all, we have to use Ohm's law and to find current in the circuit because without current we can't find potential.
Mhm.
So potential is something IR according to Ohm's law. So potential is given as 2. Current is something we have to find. Can I find the value of net resistance through this circuit? Like 20, 30 is 50.
Mhm.
20, 30, 20 is again 50 and they both are connected in parallel combination. So in
Mhm.
parallel combination, resistance is R1 times R2 divided by R1 plus R2.
Mhm.
So when you solve it by putting the value of R1 and R2 as 50-50, we'll get 25.
Mhm.
So I is something which is 2 by 25 amperes. So finally we got the value of current. Now, if we got the value of current, we can easily find out that what is the potential across 30 ohm resistor. So this is the value of current which we have found. As the
Mhm.
value of resistance across both the wires, like 30 20 and 20 30 and 30 20 wire is same like 50 ohm and 50 ohm. So the current that will pass through them will be I by 2 and I by 2. That is something you need to understand. If the wire has same resistance, this is also R, this is also R, and there is a current I coming into it. So across both the wires, current will be equally divide itself and pass through the wires.
Mhm.
So if we consider that fact, we can say that I by 2 or the current passing through this 30 ohm resistor would be 2 by 50 ampere.
Mhm.
This is the current that must be passing through 30 ohm resistor.
Mhm.
So if we have to find the potential, again we have to use Ohm's law. Current passing through 30 ohm resistor is 2 by 50. Resistance of the element is 30 ohm, so it is approximately 6 by 5 volts. So the potential across 30 ohm resistor would be 6 by 5 volts. So this is
Mm-hmm.
how we are used to use the voltmeter and find potential in the given circuit.
Mm-hmm.
Next thing we have is ammeter. So ammeter is something which basically a device which measures the current passing through the given wire. So in order to measure current using ammeter, we must connect ammeter in series with the component. Because if we connect it in parallel combination, possibly all the current will pass through the ammeter and we won't be able to find that how much current is actually passing through the component. Like, let me explain it to you. So assume that there is a component and we have to find that how much current is passing through this bulb. So by mistake, if we add or connected ammeter like this, what happens is that when the battery releases current, it current must pass through this resistor R, but by reaching at this point, it must have two ways. So as we already know, current will pass through that wire where the resistance is less. So
Mm-hmm.
possibly ammeter would have very less resistance. And if it would have very less resistance, most of the current will pass through it only. And the bulb, we are not able to find out that how much current is passing through that bulb. And there must be a possibility that bulb might not glow. That is also the possible case.
Mm-hmm.
So again, remember the basics that it must be connected in series combination like this.
Mm-hmm.
So this is the resistance, or you can see the component. A bulb is connected, and then we must apply the ammeter. Because if we apply ammeter, then only we can find out that how much current is actually passing through this bulb.
Mm-hmm.
Along with that how much current is passing through the bulb, we can also find out that how much power it is consuming. That we'll be doing in the later phase of this lecture. But as of now, we'll be looking at how can we calculate that current passing through it. Again, through a problem. So remember it. It is an ammeter. It may contain some resistance or it may has some resistance. And if there is a resistance there in ammeter, we must consider that resistance in series with it.
Mm-hmm.
Might be represented by smaller. So that is the resistance of the voltmeter, ammeter. Resistance of ammeter. If it is there. So did you understand? Like what is ammeter?
Mm-hmm.
All right. So there's one more thing about ammeter which we're going to just look now. The question is to convert a galvanometer into an ammeter, one needs to connect a. Now, what does it mean? Like, what is galvanometer? How does it came? Any idea?
Mm-hmm. No, I've never heard of this term.
So, galvanometer is again a device which also measures the current. Like, if this device measures the current, so why we studied about ammeter? So the reason is ammeter is a device which measures the current of higher order. Higher order means like which has the value like 1 ampere, 2 ampere, 3 ampere, something like that, basically a whole number. But galvanometer is a device which measures the current of very small order.
Mhm.
Very small means like very small in milliamperes,
Mhm.
whereas it measures the current of higher order that is in amperes. So that's
Mhm.
why we do have a device, galvanometer, which measures the current. So can you give me a practical application where we actually use galvanometer to find the current in the circuit?
Mm.
So first of all, let me give you the examples that where we actually find out ammeter or the
Mhm.
current using ammeter. So whatever circuit you look around yourself, the current passing through that circuit can be measured by ammeter. That is
Mhm.
a very simple thing. You can use it like everywhere, wherever you are, wherever there is circuit, we can use ammeter. So ammeter is fine. It is something which is very commonly used by all the electricians or technicians who does repair work. But galvanometer is something which is used by those technicians or you can say those engineers which actually measures the current that passes through a very small circuit, and that small circuit can be a circuit of your smartphone. The smartphone do has that current thing which it uses to work. So in order to measure that amount of that order of current, we
Mhm.
may use galvanometer. Have you seen a phone or a smartphone from inside like that? How does it looks? Like a broken one.
Mhm.
Have you seen?
Like, yeah, yeah.
So basically, all the stuff there inside a smartphone contains a circuit, and that circuit is nothing but a small MCB. That small MCB, or you can say the motherboard of the circuit, motherboard of the phone,
Mhm.
contains all the circuits, and in those circuits, current flows. So in order to measure that current, whenever there is a defect in the phone, we do use galvanometer. So let us
Mhm.
understand that how can we use the galvanometer. So the question says to convert a galvanometer into an ammeter, like in order to use galvanometer as an ammeter, like in some case, like someone doesn't have ammeter to measure the current, but he can't use galvanometer. So how he can actually use galvanometer to make it work like an ammeter? So the question says, how can we convert a galvanometer into an ammeter? One needs to connect a. Now there is a condition whenever we are connecting galvanometer through an ammeter, converting galvanometer into an ammeter. We need to connect a small resistance. That small resistance is something is very small in magnitude. I'm talking about a small resistance which has very less magnitude or a very small order, and that resistance is sometimes called shunt.
Mhm.
So the question is, how can we connect that shunt to make a galvanometer into an ammeter? So remember this, you might be using this somewhere in the class someday. Into an ammeter, one needs to connect a shunt that should be of low resistance in a parallel combination.
Mhm.
So whenever we are making a galvanometer, an ammeter, we must connect a shunt in parallel combination. So remember this. This is something you can learn. All right.
Mhm.
So another question. Question says what is the reading of voltmeter and ammeter? So voltmeter is something which is connected across 2 ohm resistor, which we can easily see in the diagram.
Mhm.
But there is no ammeter. So if there is no ammeter, we can assume that the ammeter must be connected in series somewhere here.
Mhm.
So how can we find the voltmeter reading and ammeter reading? Again, for finding ammeter reading, we'll use Ohm's law. Ohm's law
Mhm.
says V is something I times R. And if we have to find I, we can simply divide potential by resistance, and that too net resistance. So what is the potential of this circuit?
Um, that's the
It's given in the question.
divided by um 1 sec. You have to first calculate the 1/2 plus 1/4 though, no? The resistance.
No,
And then
we do have to do that, but not in parallel combination. They are not connected this way.
oh, so it's
They are
60 over
connected this way. So how do we solve it? First of
oh
all, tell me what is the value of the potential of the
60.
battery, and what should be the net resistance now? Like the sum of these two, because these are series combination, so it should be R1 plus R2 only. So it is going to be 6.
Yeah,
So what is the current?
10 amperes.
10 amperes. So we have to find the reading of this voltmeter. So V is
Mhm.
nothing but IR. We know the
Mhm.
current passing through is 10 amperes. So it should be 10 times the resistance of the component, which is 2. So it is going to be 20 volts. So this is going to be the reading of voltmeter.
Mhm.
Whereas we have already found out the reading of ammeter. This is going to be the reading of ammeter.
Mhm.
So in some cases, they do ask you. Let's move ahead. Another question, again, this is something which you have to explain in terms of variables. And here the voltmeter is connected in series combination. So we won't be able to measure the potential of the resistance. So we won't consider it V, we consider it A, as ammeter is something which can be connected in parallel series, not the
Mhm.
voltmeter. So ammeter's reading would be what it would be V by R, V divided by R. That's it.
Mhm.
Whereas the voltmeter reading would be V only. Why V? Because the circuit only has one component which will use the potential. So the potential across this resistance must be V only.
Mhm.
So what I want is that you should understand that if there is one component, two component, or any other number of components are there, we just have to understand that how can we find the current, and once we find the current, just multiply the current with that value of resistance in it. You can find out the reading of voltmeter. That's it.
Mhm.
So again, there is a question, and the question says that the voltmeter now has some resistance, or you can say this is some component which is connected, which has some resistance of 40 ohms. So just tell
Mhm.
me first of all, what should be the current that is flowing into the from the circuit?
60 volts over yeah.
So it should be 1 ampere.
Mhm.
So let us check out the reading of voltmeter now. So as the resistance is equal to the voltage, so it should be 20 volt and it should be 50 volt, 40 volt. How do we
Mhm.
find it? By multiplying current times R1 by multiplying current times R2. So it is going to be 1.
1 times 20 and 1 times 40.
Yes. So that's why I can say it directly that it would be 20 volts and 40 volts. Another question. Now just try this question out. So when it says that the voltmeter is applied across this 2 ohm resistor, it means it must be connected in parallel, not in series.
Mm-hmm.
Because you can't use voltmeter to be connected as a series part of the circuit.
So you have to use the 1 over R1 plus 1 over
Yes, we
R
have to use that.
plus 1 over R3. Mm. So
Yes. So RP is going to be 1 by 2 plus 1 by 3 plus 1 by 6.
mm-hmm.
So RP is going to be 6 as a denominator plus 2 plus 1, that is 7 by 6. So RP is
6 by 7
6
ohms.
by 7 ohms. This is 4 ohm connected in parallel combination. So series combination. So R net is going to be 6 by 7 plus 4.
Oh, yeah.
So 6 plus 28 by 7, that is 34 by 7. This is
Mm-hmm.
going to be the net resistance of the circuit. We have to find out the current. So current is going to be V by R. V is 60. R is something 34 times 7. If we solve it, we got 210 by 17 amperes.
Mm-hmm.
So that must be passing through 4 ohm and
Yeah.
it got separated here, but
Mm-hmm.
it got separated here. So now how can we solve it? Again, by using the value of potential. Can we find out the potential across this particular case, like this whole system, three resistors individually? Yes, we can. So potential is again I times R.
Mm-hmm.
So I is something which is 210 by 17. But what is the net resistance of these three wires? It is 6 by 7, which you already found. So we just multiply it. We solve it, we'll get 30 into 6, that is 180 by 17 volts. So this much potential must be there.
Yeah.
So the potential across these 2 ohm resistors is also 180 by 17 volts.
Mm-hmm.
Again, there are some questions, you can practice them and check it out that how can we use them. Another question, and the question says the figure A and B are electrical circuits. The instrument are ideal in figure A. Ideal means no internal resistance. This is what ideal means.
Mm-hmm.
While there is resistance are marked in figure B. So these are non-ideal resistors. So it has resistance 2 ohm, it has resistance 0.5 ohm. So each voltmeter and ammeter has resistance.
Mm-hmm.
So let us try to find out the readings. So how their readings going to be affected? Let us find out this in first case and then in second case. So you will learn a lot in this question about voltmeter and their internal resistance. So in case 1, we can find out current directly. It is V by R. P is something 10. R is something 2.5. Can you spot that 2.5?
Mm-hmm. Where is the 2.5?
Yeah, that's what I'm asking. Can you find out that how I write 2.5 there?
Because you added the 2 plus the 0.5 ohms.
Yeah. Why? Because they are supposed to be connected in series. So
How are
this
they?
must be a series combination. Because whenever we are looking into a circuit, in order to find out the readings of voltmeter and ammeter, we don't assume that they're connected across because they have internal no resistance, so it won't affect the circuit's reading. So I can assume this circuit to be like this only,
Um, is it
nothing
because they're
else.
not directly below each other? Like
Is it because of what?
direct is it because they're not directly across each other? Or I still don't get why it's a series combination.
Because whenever we have an idle instrument connected in a circuit, their internal resistance is supposed to be zero. So if the internal resistance is supposed to be zero, it simply means that no current will pass through them.
Mm-hmm.
And if the no current will pass through them, they won't affect the circuit. But still they are connected in the circuit so that they can calculate the readings. They can calculate the current and the potential. But
Okay.
if they have any sort of resistance, like this is there in the second case, which we also going to find out, if there is any resistance, current will pass through them,
Mm-hmm.
which change the readings. So that difference we are going to learn here through this question, that how much difference is there if there is a resistance of the voltmeter and ammeters. So
Mm-hmm.
is it clear that how I write 2.5, like why I consider them in a series?
Yeah.
Because these two resistors are connected in series if you don't consider that V and ammeter are there.
Oh,
But here
okay.
it would not be like that. We can't
Yeah.
consider them to be in
Right.
resist series. We have to solve the circuit as it is. So it is
Okay.
going to be 4 amperes.
Mm-hmm.
So the reading of ammeter, we can say 4 amperes, right?
Mm-hmm.
But for readings of voltmeter, we have to use again Ohm's law. So V is nothing but I times R. I is something which we got as 4 and R is something which is 2. Because 2 is the resistor across which we have to find the readings of the voltmeter. So it should
Mm-hmm.
be 4 times 2. So V is going to be 8 volts. So that is the readings of the voltmeter and that is the readings of the ammeter.
Mm-hmm.
So this is the case 1 and these are the readings. Now let us see what would happen if the internal resistance of the voltmeter and ammeter was there. Now we have to consider this circuit as it look like. So 2 ohm and 2 ohm are connected in parallel combination. Can you give me the net resistance of these two?
Yeah. Um, so it's 1/2 plus 1/2, which is just one.
Yes, it is
One
1.
one
Now, what is the resistance, net resistance of the circuit? Tell me.
um then so that's 1 plus point 5 plus 2.5.
1 plus how? 2.5. Where did you get that 2.5?
No, you don't add that, right? Because you're given the VNA. Oh, that was for the first one. Never mind. So do you have to add point 0.5? Or
Yes,
is
because if you look at the circuit after the consideration of 2 ohms potential resistance of voltmeter, the circuit would look like this. Yeah, this is supposed to be 1, this is supposed to be zero point 0.5, and this is also supposed to be zero point 0.5. Again, remember, this is ammeter's resistance.
mm-hmm.
So what is the net resistance now?
So it's 1.5. Wait, 10 over 1.5, right?
No, look at the diagram carefully. It should be zero point 0.5, zero point 0.5, and 1. That is 2, the readings of ammeter would change to 5 amperes. Whereas in the first case, what was it?
4 amperes.
That is how the readings changes. Similarly, if you consider the voltmeter reading, how can we find it?
Mm,
So this voltmeter is connected across 2 ohms in parallel combination. So there must be some potential like this and this. So
mm,
what we can do is we can just put multiply the value of current with this value, like the net resistance of these two. The
mm,
voltmeters reading we would get is net resistance R times value of current, that is 5, which is also 5 volts.
mm,
So you can see if we consider the values of if we have the resistance value of internal of voltmeter and ammeter, the value of their readings like changes a lot.
mm,
So this is how they affect the internal resistance. This is how internal resistance of the instrument affect the circuit's reading, and
mm.
sometimes the flow of current as well. So this is again one such question. You can try this in homework. Next we have is single loop circuit. Like what is single loop circuit? So single loop circuits are those circuits which we have just solved, like them. So this is a single loop circuit. As I told you, when we are solving these circuits using Kirchhoff's law, we must assume the direction, and that direction is something which is represented by the name of the loop. So if I write in loop A, B, C, D, A, so what does it mean? It means you started reading the circuit,
Like it goes from A to B, B to C, C to D, and then back to A.
yeah, from A ending back to A, something like that. So what direction it is?
Mm,
Clockwise.
yeah.
And sometimes if the loop says like its name is A, D, C, D, A, so it should be anti-clockwise,
Mm,
starting from A
ending at A.
through this through D this time,
Mm,
ending back to A. So such loops are called single loop circuit, and we might be solving these circuits in some numericals in order to find the value of unknown. And that
mm,
unknown most of the time can be voltmeter, can be ammeter, because these are something which are there to be asked in the questions.
mm,
Next, we have a circuit, and the circuit asks what should be the current that is supposed to go through like this. So this is something I called single loop circuit. And here, before solving such circuit, in order to find out the value of current, we should name it like A, B, C, D. And whenever we are reading the circuit, we have to name it. So I'll say in loop A, B, C, D, A. So I'm supposed to read this circuit in this manner. That is anti-clockwise.
mm.
So remember, whenever we are writing Kirchhoff's law equation, that is KCL or KVL, we are actually using Ohm's law only. How we are supposed to write the equation, that is the important thing. Let's try to understand it. So we are supposed to read the circuit from A to B, and we see that the current is flowing in this direction, and we are also going from A to B. So the direction of current and our reading sense of the circuit is
Mhm.
both same, right?
Yeah.
So we'll write the whole thing as I 4 times I, like this current times this resistance
Mhm.
on right hand side as per the Ohm's law equation. Then we go from B to C, there is nothing, so we won't write anything. From C to D, there are many things. Like, so
Mhm.
if current is going through this way, so it must be going through this. So again, current and my reading sense is same. So it should be plus I times 1, like I times value of resistance.
Mhm.
Next, we got a battery, and when we are going from C to D, the batteries, which plate is something which we are exiting from? Positive plate. Like I told you that the bigger plate is sometimes bigger plate is positive in nature and smaller plate is negative in nature. So we are
Mhm.
exiting from the positive side of the plate of the battery. So we are supposed to write 5 volts in the left hand side as per the V is equals to IR equation from Ohm. So this is something we call KCL and KVL. Then again we got one resistor of 1 ohm. So it should be I times 1 once again. Now we are exiting from the positive side once again. So it should be plus 2.
Mhm.
So this is how we are supposed to write the value of the basically how to write the equation through KVL. So it should be 7 is equals to 4 times I plus I. So it is going to be 7 is going to be like what? 6I.
Mhm.
So I is going to be 7 by 6. It is approximately 1.140
Mhm.
means 640 means 6. This much amperes. So the closest value from this answer to the option is 1 ampere. So we are going with B option. Did you understand that how we are actually applying KCL and KVL?
Yeah.
KVL is Kirchhoff's voltage law and KCL is Kirchhoff's current law.
Mhm.
Next type of circuit we have is Wheatstone Bridge. So in Wheatstone Bridge, the resistors are supposed to be connected in this way. So this is R1, R2, R3, and R4. And there must be some resistance R5. And the circuit is connected to a battery, again of V potential, and there must be a current flowing through the battery.
Mhm.
So this arrangement of 5 resistors is called Wheatstone bridge. So whenever you found that this is the arrangement of the circuit, we will call that circuit a Wheatstone bridge.
Mhm.
So the catch is there is a special type of Wheatstone bridge which is known as ideal Wheatstone bridge. Solving ideal Wheatstone bridge is very easy because for ideal Wheatstone bridge, what we have is the ratios of resistance look like this. R1 by R2 must be equals to R4 by R3. So if there is a Wheatstone bridge, there is no current supposed to be passing through the middle wire. So
Mhm.
current through that middle wire is supposed to be zero in ideal case only. If there is an ideal case, then only we are supposed to follow this. So in some bridges, in some circuits, they're supposed to be a Wheatstone bridge, and in order to solve that Wheatstone bridge, you do use that ideal condition if it exists, like current through this wire is supposed to be zero. It becomes ideal. So remember
Mhm.
the arrangement and the circuit formation. This is how it looks.
Mhm.
So the question says if what is the equivalent resistance between A and B? So in order to find the equivalent resistance between A and B, we can see and we can tell that this is nothing but a Wheatstone bridge.
Mhm.
So before solving Wheatstone bridge by using KVL, like Kirchhoff's voltage law, we can first actually check this thing that if this Wheatstone bridge is, if this is an ideal Wheatstone bridge, and in ideal Wheatstone bridge, current through the middle wire like this,
Mhm.
zero. So let us see if it is ideal or not. What is the condition of ideal Wheatstone bridge? R1 by R2 must be equals to R4 by R3. So here it is supposed to be R1, it is supposed to be R2, it is supposed to be R3, it is supposed to be R4. Are their
Mhm.
ratios equal? Check and tell me.
Yeah.
So yes, we can say 3 by 4 is always 6 by 8. Hence, R1 by R2 is equals to R4 by R3.
Mhm.
Therefore, Ig is going to be 0.
Mhm.
So if Ig is going to be 0, you can actually short that wire. And the circuit looks like this. Now, the new circuit which we have will look like this. 3 ohm resistor, 4 ohm resistor, 6 ohm resistor, 8 ohm resistor.
Mhm.
This is point A, this is point B. So in order to solve them, what we can do? We can use the ideal knowledge of solving resistors. These two are in series individually and then in parallel.
Yeah.
So 3, 4 is going to be 7,
And then
6,
it's still
8
8.
is going to be 14.
Mhm.
When we solve them for ideal condition, like for net resistance, it is going to be R1 R2 by R1 plus R2.
Mhm.
7 times 14 divided by 7 plus 14,
Mhm.
which is going to be 7 times 14 by 21. That is 14 by 3. The net resistance is going to be what? 14 by 3 ohm. So D should be our correct answer. Got it?
Yeah.
So in this chapter or in this unit, there is more application part. Whatever we are going to learn, we are just going to directly apply that thing in a numerical or in some problem. Because uh, there is nothing like why is it happening? Because it is a need, and this through this only all everything around us works. Otherwise, nothing works. So the
Mhm.
electrical engineers who are actually study electrical engineering, what they study is they study about these things in like very detail, like how this thing actually works, how can we actually create a whole circuit of wires at our home. Like we can learn if they learn everything like that. Like
Mm-hmm.
a person like you or a me, they don't have a knowledge of how an electrician actually fits the wire or do wiring of a place. But an electrical engineer has that information or has that knowledge. So
Mm-hmm.
this is the again another branch of physics which deals completely with this thing only. So that's why we have more questions instead of that theory and derivation part. Like very hardly any derivation here. So again we have a question. You can try that question. So there are so many questions which are being asked here.
Yeah.
This is something we can try. This is another form of Wheatstone Bridge.
Mm-hmm.
Like if you just put these 2 points A and B in the farthest position, you will find the circuit would look like this. Can you say that this is the
Yeah.
circuit?
Mm-hmm.
If I label the points also, this is how it is supposed to look. D last C. And the value of each resistance is R only.
Mm-hmm.
So is this an ideal Wheatstone bridge? Is it satisfies that condition of same
Mm,
ratio?
no.
This is one resistance, this is another resistance, this is third resistance, and this is the fourth one. This was supposed to be R1, this was supposed to be R2, this is supposed to be R3, this is supposed to be R4.
Mm-hmm.
So is R1 by R2 equals to R4 by R3?
Okay, then they do. They have the same ratio.
Yes, they are equal. The ratio is equal. So this is an ideal Wheatstone bridge, and we can use that condition of no current passing through this wire.
Mm,
So if there is no current passing through this wire, it means we can assume these to be in series, these to be in series, and both the wires in parallel combination. So it is
mm-hmm.
going to be 2R, it is also going to be 2R. So the net resistance RP is going to be 2R times 2R divided by 4R, 2R plus 2R. So it is 4R square by 4R. So it
Mm-hmm.
is going to be
Four,
R only.
4/4. So yeah.
4R square by 4R. It is going to be R only.
Mm-hmm.
So we got the value of resistance,
Yeah.
and the question asks the current flowing in AFCEBY, AFCEB, AFCEB wire. The current flowing in AFCEB wire. AFCEB wire. This is what they are asking. All right. So we got the value of current resistance.
Mm-hmm.
And in order to find out the value of current, it is given that the battery is of 4 volt. All right. So using Ohm's law again, V is nothing but IR.
Yeah.
Potential is 4, current is something we have to find, and net resistance of the circuit is find out to be R. So current is going to be 4 by R. Also, I just told you, like in the previous questions, that whenever there is the same resistance in two wires, like this is R, this is R, this is R, this is R. So current which needs to be divided across these two wires would be what? It would be of same magnitude. Like
Mm-hmm.
current would be of same magnitude. So I by 2 will go there and I by 2 will go there. So using Ohm's law, we can say that the half value of 4 by R would be 2 by R. So the current through AFCEP wire is going to be 2 by R.
Mm-hmm.
Which option matches this?
D.
This is how you're supposed to do them. So unbalanced Wheatstone bridges are those for which R1 by R2 is not equals to R4 by R3.
Mm-hmm.
Like for those Wheatstone bridges for which this ratio is not equal, like R1, R2, R3, R4. So for those circuits for which the ratios are not equal, so Ig that is passing through it, the middle wire, is
Mm-hmm.
also not equals to 0. And that makes it unbalanced Wheatstone bridge. So unbalanced Wheatstone bridges are very complicated to solve because you have to apply KVL, you have to form two, three equations and then solve them. That makes them very difficult to solve. So we are not going to discuss those type of numericals here. Next we have is battery series combination. Like all the components of the circuit, resistors, bulb, or whatever you can found, like capacitor, we do connect batteries in series and in parallel combination as well.
Mm-hmm.
So how they're gonna look? Like for a battery, considering that there is some internal resistance also, I would say that they would look like this.
Mm-hmm.
Each pair of cell and resistance represents the battery. So this is the combination which we can say that this is a a series combination of batteries. And for each battery, whatever EMF and internal resistance is there, they can be calculated easily. And also, if we want to shift all the batteries or replace all the batteries by a single battery,
Mm-hmm.
what should be the magnitude of that EMF and that internal resistance of the new or the bigger battery can be calculated. So it is something we called E effective. It is something we called R effective. So that
Mm-hmm.
net effective EMF of the new battery, which is just like the combination of these three, would be of nothing but sum of all the potentials of the given four batteries. Like that, how simple it is. You just need to add them. You can get the EMF of the obtained battery. Then,
Mm-hmm.
if we want to find out the net resistance of that battery, so that net resistance can also be calculated in the same manner. Like that R effective is going to be R1 plus R2 plus R3.
Mm-hmm.
Just add them and you get the value of resistance also. But in parallel combination, it's not that same, and which this is something which we have already discussed in the last class, and I hope you remember that. And if
Mm-hmm.
not, go through the recording.
Yeah.
In the recording, we discussed this parallel combinations,
Mm-hmm.
EMF effectives value, and R effectives value in that lesson. So just go through it to remember it.
Yeah. Yeah.
The last thing, or you can say the last topic of this chapter is power. So before actually understanding power, let's see that what we have seen so far. I told you initially that the force which acts between the charges is called electrostatic force, and the magnitude of that force is nothing but kq1 q2 by r square.
Mm-hmm.
Then we came across electric field, and electric field is something which is kq by r square. We defined electric field in such a way that it is nothing but the force experienced by the charged particle.
Mm-hmm.
So just remember the situation when the charged particle was actually experiencing force. It must have done some work against it.
Mm-hmm.
And in generally circuits, that work is something which is done because of battery only. Like the charged particle will be able to do work against this electrostatic force which is existing between the multiple charges present in the conductor. That work is something done because of the battery there in the circuit. Like it is giving that force to work that charge to move in the circuit to do that current thing. So work is done by the battery because of the battery. So we can say whenever there is a force and against this force there is some work. So that work means that there is some sort of energy.
Mm-hmm.
Also, if you want to define the power to do that work against that force, is something work done per unit time. Like power is something which is defined as rate of doing work. Like by how good or bad rate you can do work. Like how
Mm-hmm.
fast and how slow you can do work. That is something defines the power. Like for example, let me
Power
give
is
you
more
a
of
very
a force type of thing, right?
yes. What?
Yeah.
I didn't get you. What you said?
Oh, like power is like more of a force, not like slow or fast, right?
Mm, no, you should not say it like that. Power is something which is defined like by how fast a particular device or instrument works or perform work.
Okay.
So the force which is acting, that is something which remains constant, but the efficiency or the performance of the circuit will increase or the performance of the battery will increase. That is something which defines its good power. Let me give you a very basic example, a few examples to understand this power thing. So just suppose that there are two cranes. One crane is lifting a car, like a scrapped
Mm-hmm.
car, through a height of 100 meters, let's say. In 2 minutes, it is able to lift that car up to 100 meters.
Mm-hmm.
That crane must have some good power, right? That's why it is able to pull that up, a huge car of huge mass. Another crane does the same work, like pulling that car up to 100 meters of height. But it took 10 minutes to do that.
Mm-hmm.
So we can say that the crane one, which lifted the
Yeah.
same thing in 2 minutes, will have
They
more
went.
power.
Mm-hmm.
So how does that more power came? Because of the engine.
Mm-hmm.
So power is something defined that how fast you can perform a work. So it also defines the efficiency of an engine or like the performance of an engine. So for whichsoever automobile vehicle has more power, like its engine has more power, it is supposed to perform well, like in a fast thing. That's
Mm-hmm.
why you saw, if you had interest, Automobiles with higher engine volume. I don't know what actually goes there, but here it is supposed to be like 150, 250 cc's of engine, like cubic centimeter. So if you had that interest, so every vehicle has an engine which volume can be measured in cc. So if there's a
Okay.
vehicle, just go and ask the concerned person that what is the engine capacity or the volume of the engine of this vehicle.
Mm-hmm.
So you can relate it well. I don't know which unit they follow here, there in, but
Mm-hmm.
here we follow cc, so cubic centimeter. So just maybe a different reference. They might use cubic meters. That is also the unit of measuring volume. So they might use that, or even cubic millimeters. That is also possible.
Okay.
So if any of the three unit you heard, so just remember it. You can calculate. You can look at the power of the vehicle and guess that how much speed it can acquire in small time. So if an automobile has higher engine volume, so it's supposed to perform same work in less time.
Mm-hmm.
And if it is able to perform the same work in less time, it means more speed. So all the supercars we have, if you look at their engine's volume, it is huge. Just check it out. You'll be more into the subject. Like compare two things. Engine of car which you use, like its volume for your daily work or whatever it is, and engine of a supercar. Compare it and make sure you tell me in the next class that what is the difference between these two engines. Then you
Wait,
can
the engine of
auto.
a car and engine of okay, the car you use.
So when you compare them, you can easily find out because of the huge engine capacity of supercars, they do have higher speed. That is the reason. So power tells so much thing about a automobile, or you can say a device or an instrument. So power is work done upon time. That is something we should consider.
Mm-hmm.
So in order to calculate power for these circuits, we have this relation V square by R.
Mm-hmm.
Remember this. And this electric circuit thing, we are using this formula for calculating power.
Mm-hmm.
I won't comment on that how this formula came, but yes, we do have it. Although if it is a complete course, I would have tell you that how this formula came and how we're supposed to
Mm-hmm.
derive it. Let us do a simple problem in order to find out the power, like which is more brighter out of these two bulbs. That is what we are supposed to answer here. So in order to find that which one is more brighter, we have to find out the power, that what is the power rating of them.
Mm-hmm.
So one has 10-watt power rating, another has 40-watt power rating. So power is something we saw that it is nothing but V by R.
Mm-hmm.
Can I place I R in place of V
Yeah.
using Ohm's law? So it will become I square R,
Mm-hmm.
right?
Yeah.
So we have two bulbs. You can simply answer them. If the resistance is different, like more for the same current, there will be more power. Like this is how the different
Mm-hmm.
watt bulb give different watt of brightness. So if it is 40 watt, it would be more brighter
Mm-hmm.
because it doesn't depend upon the brightness doesn't depend upon the current, it depends upon the resistance only,
Mm-hmm.
and it will be less brighter, being connected in series. Now, this is the question which you can answer like directly without even considering the values in the circuit. Last but not the least, energy losses in the circuit. So first
Mm-hmm.
of all, we have to understand that which kind of energy losses are there. Like if there is a current going on through a circuit, what kind of energy loss which we may experience here? So the answer is that loss should be heating loss. Like heating loss, you can say energy might get lost in the form of heat.
Mm-hmm.
So if energy is being lost in the form of heat, that loss is something which is huge. Like earlier, we are using lighter diameter wire for transporting electricity. So
Mm-hmm.
if it has a lesser diameter or lesser area, it would be of more resistance. And if it's a bigger diameter, it would be of less resistance.
Mm-hmm.
And if it would be of more resistance, it would heat more. Whereas the bigger diameter wire heat less.
Less.
So that is why the transformer, the local transformer of our society generally has that connection that is directly coming out from some power plant of your
Mm-hmm.
of your area, and that wire, that thickness of wire is huge in comparison to the wires which are being there in our houses.
Mm-hmm.
So that thickness is basically to reduce the heat produced or the heat loss.
Mm-hmm.
So now the question is how we can calculate this heat loss. We can calculate this heat loss by using the formula of power. Power is something we found, it is I square R also. Like it is V square by R, but it is I square R also. Now
Mm-hmm.
power is something which is also defined as heat loss per second. Like whatever amount of heat loss there is by the rate of per second, it is because of the power. So that is how power is also defined. So we can write H by T in place of power, and we get heat as I square RT.
Mm-hmm.
So if we put the values of the given component in this formula, we can calculate the energy loss in the form of heat. And the unit of energy is going to be joules. All right.
Mm-hmm.
So we can actually we can actually do that problem. It is not that much based on power thing, but you can do it. You can try it out. Next, we have this particular form question. The question says, is the power dissipated in the 6 ohm resistor, like this resistor,
Mm-hmm.
with 36 watt? The potential difference across 2 ohm resistor is, what is the potential difference across this resistor? So this is how you should look this question now. You have power given, but not the current passing through it. So if there is current in place of power given in the circuit, can you find out the potential across this 2 ohm resistor? Because we did so many questions like that, having
Yeah.
current and finding potential. So can we relate power by current? Yes, we can. Power is nothing but I square R. From here, we can calculate the current passing through this thing. And after finding the current, we can use whatever we did in the last questions to
Mm-hmm.
find out the potential across 2 ohm resistor. So current is going to be 36 by 4, not 6, square root. It is coming out to be 2 amperes. So
Mm-hmm.
if 2 amperes is passing through this, the potential becomes 18 volts. And if you apply the same potential across 6 ohm, so the current passing through it is 3 amperes. So the total
Mm-hmm.
current which should be passing through this 2 ohm resistor would be 5 amperes. So the
Mm-hmm.
potential across this is going to be 2 times 5, that is 10 volts.
Mm-hmm.
This is the answer. Like these questions are something which doesn't contain much calculation, but good problem solving attitude. Like you have done a lot of problems before solving any question, because it might be difficult to think that which thing we actually need to apply. But if you have solved a lot of problems, like first examples and then some different problems, and then you're trying a new problem, you would have easily done it.
Mm-hmm.
Again, there are some questions and you should do them. You can try that question also. We have to find the total power dissipated in watt. So how can we find the power? Power is nothing but V square by R. That R is something which needs to be net. So 18
Mm-hmm.
volt battery is given. We have to find R. How can we find it? Let us see the circuit properly first. So this circuit is something which can also be drawn this way.
Mm-hmm.
I guess now you can find the net resistance easily. The net resistance of this combination would be 3 times 6 by 6 plus 3, that is going to be 2 ohm.
And
It is
then
4,
plus.
2 plus 4 is 6 ohm. It
Mm-hmm.
is 18 volt, so current going to be 18 by 6, that is 3 ampere.
Is it not 18 squared?
No, I just find out the value of current.
Oh, okay.
So current would be 3 amperes. We
Yeah.
can calculate the power now.
Okay. Yeah.
Power is
So.
going to be V square by R. V is 18 square by R. R is what is net resistance? Net resistance of 6. So either you
Mm-hmm.
can use this relation, also you can use I square R. So I is 3 square and R is 6.
Mm-hmm.
These two values are supposed to be same.
Mm-hmm.
So you can solve them and check them out that what it is. Let us do it right now. It is 54. You can also do it and check it out whether it is 54 or not. For both the relations, it should be 54 only.
Mm-hmm.
You can check it out later on while revising things. Again, we have some questions and you can try them out. And it's better to try these questions out. I have put a lot of questions in these slide because these are the topics which requires a lot of practice. If
Yeah.
you are practicing regularly, then only you'll be able to solve these questions. If you just let it go like for even a month or 15 days, it would be completely new. Like you
Mm-hmm.
might not be have an idea that how to solve or relate them. So that is what you should do and problem and solve as many questions as you can.